Hey everyone, Turf Teacher here. Welcome to the lecture entitled Calibration Without Math. This information comes directly to you from NC State, written by Dr. Miller and Dr. Reynolds. I actually took this course under Dr. Reynolds. I went to a CEU class for pesticides, maintaining my hours for my CEUs. Met Dr. Reynolds, loved this lecture, and wanted to incorporate it into this course. Dr. Reynolds is now down at Texas A&M University, but Dr. Miller is still down at NC State. So guys, this is good information that those two gentlemen put together for this course. And I like it, and I wanted to show it to you guys to show you that you don't necessarily have to be so scared of the pesticide math that you may need to use. I know we've seen some tough math problems so far in this course, and I wanted to incorporate this and show you that there's a little easier ways to do it, and then there's ways that you can calibrate equipment that doesn't use so much math. So let's get started with it. Can you calibrate a sprayer or a spreader without using math? To find out, let's see exactly what the definition of calibration is. According to Webster's dictionary, it is to determine, check, or rectify the graduation of any instrument giving quantitative measurements. Sounds very scientific, guys. Well, we are professional people applying pesticides. Guys, this is a legit business. This is a dangerous business. So we need to maybe sometimes put on the old lab coat. To standardize as a measuring instrument by determining the deviation from a standard so as to ascertain the proper correction factors. Hey, that's pretty good there. Well, where are we finding this standard information, ladies and gentlemen? What is it that we've talked about so far, especially in Unit 1 of this course? We talked about the label. The label is going to tell you the standard. This product needs to be put out at X amount of ounces per 1,000 square feet. There's your standard. And so we can use that standard to calibrate our equipment, to adjust precisely for a particular function, and then to measure precisely, especially to measure against the standard. I like that last one, to measure precisely our pesticides against the standard of the label. Good information here, guys. So knowing that, is it feasible to have calibration without math? Absolutely not. You can't. We're going to have to do some math. However, there are several ways to calibrate, some of which involve much less math than others. So that should put a smile on your face. We're not going to have to do so much math on certain situations, but there's going to be instances where you are going to have to bring in some of the old math problems and get out the calculator. With that being said, the title of this lecture should be Calibration Without Much Math. Now, that's a pretty good joke that they threw in there for you. So calibration without much math. Guys, it's not scary, and that's what I wanted to show you. I think people get intimidated sometimes when they start seeing these pesticide calculations, and it's not. We just need to practice them, do the problems, get used to doing them, and read the labels. And again, like I said, talk to your dealers, talk to your Department of Agriculture extension agents. Those individuals are there to help you, and they can help you figure out some of these calculations and calibrations, if you know them and you just talk to them, give them a call. I like to break down calibration into two methods. We have traditional and we have the alternative method. Traditional method, the advantages, most precise. So that's probably going to involve a little bit of math if it's real precise, right? Recommended for fine turfs like putting greens, tee boxes and things, baseball fields. Recommended when applying expensive products due to cost control. We want to use it when we're using fungicide heritage. That stuff's high dollar. Definitely the best way to go if you have the time, manpower, and expertise to do so. Now, in my previous lectures, guys, I've talked about having your technicians calibrate their equipment every morning. That's going to save you time, it's going to save you money, and I know it's going to take them, some time in the mornings, but that's something they need to do. Just like when they come in the afternoons, they need to clean out those tanks and spreaders, clean the equipment, properly dispose of the empty containers, properly wash and dry their PPE that they've used or dispose of it properly. There's just needs to be time for certain things, and this traditional method, if you're doing high dollar putting greens, baseball fields, football fields, you're going to have to do that anyway, guys. So get used to doing it. A 4-ounce bottle of this heritage fungicide is around 125 bucks. Yikes. So we got 16 ounces. That's in a pound, right? So a pound of this stuff's $500. Holy smoly. You want to use the traditional method here because you want to be right on the money, as they say, to save that money when applying a product like this. Some disadvantages of the traditional method of calibration. It's time consuming. It's very math oriented, but don't freak out. It can be overkill in certain situations and can be hard to relay down the chain of command. So you've got a new technician working for you. They've got their certification. They're just a little nervous. They want to make sure they're making their customers happy and making you, the boss, happy. They may not want to do some of these putting greens or some of these baseball fields yet. So they're not going to be doing the traditional method, and it might be a little hard to get them to understand until they've got some experience under their belt. Alternative method of calibration. Advantages: easy to comprehend and relay to employees. Good for quick and easy determination in the field. I like that. I can read the label and figure it out real quick. Will get you very close without the cumbersome math. And then in many situations is more than adequate to meet the turf grass needs. And so that's what we're primarily doing in our business, right? Is we're applying pesticides and fertilize to turf grass, shrub beds, and some shrubs and trees occasionally. So we'll probably be all right using this alternative method. Disadvantages: not recommended for use on the fine turf greens. We wouldn't want to use it on the baseball field or the putting greens, tee boxes like that. And it's not recommended when using products likely to damage the turf from improper application rates. If that turf grass needs to be very precise, or it burns easily, or it could die out quickly by a little more than what's called for, we wouldn't want to use this method. We'd switch back to traditional. And not recommended for expensive products due to the cost control. We looked at that heritage fungicide. We're using the traditional method there so we can be spot on, right on the money. We wouldn't want to use heritage fungicide and calibrate our equipment using the alternative method because we could waste product, and that's wasting a lot of money when it comes to that. So no matter which approach you use, calibration will have to be broken down into 2 further categories. Now, these categories: calibration of equipment that applies granular products, like that fertilizer spreader; calibration equipment that applies liquid products. Granular products. The most common product applied in granular form is fertilizer. Look at that bag of fertilizer. We got our nitrogen, phosphorus, and potassium, our NPK ratio. This one's 21:3-20. Here we have the key nutrient plant growth, 21% nitrogen in a 50-pound bag. So we got 10.5 pounds of nitrogen. Phosphorus, important for establishment. We have 3% phosphorus in a 50-pound bag, so we have 1.5 pounds of phosphorus. And then potassium will increase stress tolerance. We have 20% potassium in the 50-pound bag, so we've got 10 pounds of the potassium. So that's how to read a fertilizer ratio on the bag. 2 things you need to know to apply the proper amount of fertilizer: the square footage or acreage of the area being fertilized. So we've studied those geometric shapes, guys, in this course already, so you know how to calculate your footage and acreage. If it's more than 43,560 square feet, that's the square footage in an acre. And then we need to know the analysis of the product being applied. This is true for both the traditional as well as the alternative methods. Let's say you want to apply a complete fertilizer 2 weeks after spring green up on a bermudagrass football field. How much fertilizer do you need to buy if you are applying 1 pound of nitrogen per 1,000 square feet using a product with an analysis of 28-5-12? So we have 28% nitrogen, 5% phosphorus, and 12% potassium. Measure the football field. This can be done by stepping it off and using a tape measure or shooting it with a transit. You have done this using one of the methods and found your area to be 90,000 square feet. So, step 2 is to calculate how many pounds of nitrogen you need to apply to achieve the desired rate. Proportional method, if this, then that. So we have 1 pound per nitrogen, guys. So we're putting our 1 over the 1,000. And remember, I've always told you to break down your areas per 1,000 square feet. Well, if we've got 90,000 square feet, we've got 90 1,000 square foot areas. But we got 1 pound of nitrogen per 1,000 square feet is equivalent to X amount of pounds per nitrogen. Should have made that X a little bit bigger. And then we're putting that over the 90,000 square feet. And so we're going to cross multiply. So we have 1 pound of nitrogen times 90,000 square feet is equivalent to X pounds of nitrogen times 1,000 square feet. So X equals 90 pounds. Guys, I've told you this in the previous lectures. Break your areas down to how many 1,000 square foot blocks. Well, you already done that in your head, right? Because 90,000 square feet divided by 1,000 is 90, and we did it using the cross multiplication there. Step 3, calculate how many bags of 28, 5, 12 you need to buy to get that 90 pounds of nitrogen. So we have the 28%. Remember, we have our 28 right here. So we're going to put 0.28 over the 1 pound of fertilizer equals 90 pounds divided by X pounds of fertilizer. Cross multiply again. So 28 pounds of nitrogen times X pounds of fertilizer times 1 times 90. So we have 0.28 equals 90 pounds. We have our X over here. So X is equivalent to 321 pounds of fertilizer. And we know that fertilizer is sold in 50-pound bags, so therefore we need 6.4 bags of the 28, 5, 12 fertilizer to put the 90 pounds of nitrogen. So good math problems there. Traditional method 2, measure the football field. Again, we've got our 90,000 square feet. Given this information, you can plug it into this equation. This is the Stoichiometry. I will say it for that. I need to Google that and actually hit that little speaker button so I can hear it say that. But this is area times rate times analysis. Easy math here, guys. Again, area times rate times analysis. So 90,000 square feet times 1 pound of nitrogen over 1,000 times 1 pound of fertilizer over 0.28 equals 328 pounds of fertilizer divided by the 50 pounds of bags. We get 6.4 bags. And in the next lecture, and the final lecture that I'm recording, you'll actually, your last lecture in this course is me working out the pesticide problems on the whiteboard. But I've got one more lecture to record, and we're going to look at a lot of this type method right here. So, alternative method, the common sense approach. Measure the football field. Again, this method only works when applying at a rate of 1 pound of nutrient per 1,000 square feet. Again, I love those problems where it's per 1,000 square feet. Most fertilizer product comes in 50-pound bags. Divide the first number in the fertilizer analysis by 2. So 28 divided by 2 equals 14 pounds or 14,000 square feet. This number represents how many pounds of nitrogen are in the bag and thus how many thousand square feet this bag will cover. So it will cover 14,000 square feet. So you divide the 28 by 2. Step 3, divide the total square footage by the square footage each bag will cover. So we have 90,000 square feet. Our total area that we measured divided by the 14,000 gives us 6.4 bags of the product of the 28, 5, 12. Review, 28 divided by 2 is 14 pounds of nitrogen or 14,000 square feet. 90,000 divided by the 14,000 equals 6.4 bags of 28, 5, 12. Even though this is still 2 steps, it is much more common sense and intuitive approach, especially to those who despise algebra. So, easy enough. Instead of proportions or this method, it is 2 divisions. This method is particularly useful for small areas like you will find in the lawn care industry. The average home loan in Raleigh is 5,000 square feet. Guys, my favorite yard to mow, to do anything to. I just love the 5,000 square foot yards, and y'all have heard me talk about those postage stamp lots and how much money we can make off of those each year. For small lawns like this, it's actually just one division, no calculator required. A third of the bag will cover the average customer's lawn, 28,512, because there's 50 pounds in the bag, covers 14,000 square feet, guys. And yeah, up a little bit, if it was 15,000 square feet, it would, yes, be 100% of it. But we're good to estimate that we're gonna need a third of a bag to do this yard. And hey, you know, let's say you've got a neighborhood of 500 yards that are 5,000 square feet. You can figure out how many bags you'd need to do that total neighborhood. So guys, you see where we're going with this, and then you can calculate how much you're gonna spend on the fertilizer. Then you can calculate about how much money you're gonna make when you charge the application. So I love it when we start talking about math when it involves dollars. Liquid products. There are many products that are best applied in liquid as opposed to the granular form. These include most fungicides, many herbicides and insecticides, spoon feeding of liquid fertilizers, etc. Liquid products. As with granular calibration, there is a traditional as well as an alternative method of approaching the sprayer calibration. Two methods are the traditional, the 5940, and the alternative 1/128 acre method. And you've already seen the 1/128 YouTube video that was in Unit 1, so you're familiar with that. And then the traditional method, or the 5940 method, is the gallons per acre is equivalent to gallons per minute times 5940 divided by miles per hour divided by nozzle spacing in inches. And so our GPM is equivalent, move this around, our gallons per minute is equivalent to gallons per acre times the miles per hour times the nozzle spacing in inches divided by the 5940. GPM, gallons per minute, GPA, gallons per acre, NSI is nozzle spacing in inches, and 5940, guys, is a constant. That's just, get used to it. Burn that number in your head just like you did the 43,560. The alternative method is the 1/128 acre. The alternative method requires much of the same equipment as the 5940, but only requires one math step. Yay, right? Equipment needed. Stopwatch, something to catch the water in, like a graduated cylinder, bucket, tape measure, and flags to mark a course. And you've seen the 1/128, guys, so this should be a review for you. Check the nozzle for evenness. Measure nozzle spacing in feet, divide 340 by the nozzle spacing in feet, only math step that you're going to have to do. Measure out the distance from step 3, drive that distance forward at spraying speed, and record your time. Catch one nozzle for time in step 5, and then ounces caught is your gallons per acre. Easy stuff, guys. Easy. Remember that. Remember that from Unit 1. In order for this method to work, there are 4 things that need to be held constant: sprayer speed, boom pressure, nozzle volume, and the viscosity or the material thickness for that. 1/128, again, sprayer speed and boom pressure can be both be held constant by monitoring the gauges on your sprayer. And you need to keep an eye on those. Nozzle volume can be held constant by always using similar nozzles, and viscosity is always almost consistent. So step 1, check the nozzles for evenness. If the nozzles are not evenly distributing, they may need to be cleaned or replaced. We done that in the previous lectures. Measure the nozzle spacing in feet. Let's say the nozzle spacing in the previous picture is 1.7 feet. So 340 divided by 1.7 gives us 200 feet. This is the only step requiring math in the 1/128 method. Measure out the distance from step 3. So we're going to measure out 200 feet on a site similar to where we're applying the application. But guys, I like, if I'm calibrating my sprayer, I'm going to find some concrete or asphalt, and I'm going to do it with water only. Drive that distance forward at spraying speed and record the time. Taking 34 seconds to travel the 200 feet course is equivalent to 4 miles per hour. Catch one nozzle for the entire time it took to travel the 200 feet from step 5. Catching the water for 34 seconds using an 8004 nozzle at 40 psi yields 29 ounces. Step 7, ounces you catch is equivalent to gallons per acre. So 29 ounces caught is 29 gallons per acre. Good math here, guys. One benefit of this method is if you decide to change nozzles, all you need to do is catch the new nozzle for the same amount of time. Perfect. After this point, the rest of the work is the same as the 5940 equation. If you're applying 29 gallons per acre and you have a 150 gallon tank, you can spray 5.1 acres per tank. 150 divided by 29 is 5.1. A product such as 2,4-D that is applied at 3 quarts per acre means that you need to put 15.3 quarts of 2,4-D per tank. 3 quarts per acre times 5 and 1 is equivalent to 15.3 quarts of your 2,4-D. 2,4-D is a broadleaf herbicide, very common in the lawn care industry. Now, guys, this concludes it. I know I went fast. I went through the slides fast, but this was pretty good information. It was quick information. There wasn't much information on the slides, but slow it down. And go through this a couple times if you need to. Guys, I appreciate it. I'll see you in the next lecture.